transmisión. No, porque he sido yo el probar que contara, supongo. Se ve bien. Pero te pone, te deja en HD. Te deja en HD. Okay. Cat. Hello, 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 hello. Test, test, test. Imagen. My map. Imagen. My map. Notas. ¿Cuál? No debería. No debería. No está en el live. Sí. Te sale no porque tengo que enviarlo en el live. No que. Pues que pone. A ver. Probando, probando. Atención. Ok. 15 minutes. 15 minutes. Mm. Cerrando puertas. Ah, ya, ya. 10 minutes. Catete. Hmm. All Welcome, welcome. We're starting in 5 minutes. Starting the workshop in 5 minutes. If you want to follow along, You might want to open an editor. I use Atom because I like Atom. Can you also use VI or VS Code or whatever you like. And you might also want to install, if you haven't yet, RSpec. So use gem-install RSpec. That will get you ready to start coding along. Or you can just watch if you want. We're going to do a bit of theory. We're going to be mixing theory and practice, so we get the best of both worlds. Hey, welcome, Sebastian. How are you? Hey. Hello. Hope you're ready for some Ruby coding and TDD action. I'm going to show you what I have prepared. So we're going to be using this mind map, and I also have some notes and some code examples, some images right here. So we are ready, just waiting 2 more minutes before we start. If someone else wants to come on live. I will send you this my map. Have an image here. We send you these images and the code examples if you want. Excellent. Just we're gonna wait 1 more minute to see if someone else wants to come on live, and else we're going to get started. Okay, so let's get started. It's go time. So let's do this. So welcome to the live TDD workshop. And let me give you an overview of what we're going to be doing today. Have this mind map, and we're going to start from top to bottom, and we're going to cover all of these subjects. And we're going to be interleaving, going from a bit of theory into code examples. So specifically, I have two code examples. One where it's going to be pure Ruby, just Ruby and RSpec, no Rails. So we can see how this works. And then we're going to do a Rails example so you can see how to apply TDD inside Rails. Okay? So let's get started just by defining TDD. What is TDD? Well, TDD stands for Test Driven Development. Test Driven Development. And it's just a way to write your applications and write your test. Specifically, the way we do this is using a 3-step cycle. So let me zoom in so you can see this easier. We use a 3-step cycle, and that's the right way to do it. That's the right way to do this, to follow this cycle. What is the cycle? Well, it has 3 steps. First step is red, second step is green, last step is refactor. So what happens is that you start red, green, refactor, red, green, refactor. So it's a cycle that keeps repeating all of the time, and you're always doing one thing and you know what you're doing. So you're doing either red, green, or refactor. And of course, we're going to explain what each of these steps means. So to visualize this cycle, I made a picture right here. I have this picture, and this explains exactly how this works in a conceptual level. Okay, so we always start a red, and what that means is that we write a failing test. Yes, a failing test, and we will see exactly why it's a failing test later. Next step is to go to green. And going from red to green means that you take the failing test and you make it pass. Okay, so you write the implementation code. You write the code that makes the failing test pass. And finally, the last step in this cycle, we go from green to refactor. So we call this refactor. We don't call this blue, although the color associated with this step is blue. We call this refactor. So what is refactor? Well, refactor is just improving the code. So these steps, exactly in this step, our tests are passing. Okay? So we don't go into the refactor step until we are green. Being green means that our tests are passing. So refactor is just improving the code. It's making the code better. And when we are done with that, what happens? Well, we write a new test and we go back to red. A new failing test, and this keeps repeating. So we go back to passing the test, green, refactor, red, green, refactor, red, green, refactor. And that's TDD, that's the TDD cycle. Okay? And of course, we're going to see a practical example right now. So the code example that I want to do here, first we're going to require RSpec how to run. I'm going to explain what this example is. So this RSpec auto run means that we can have the test and the code implementation both in the same file. Okay, so that's what auto run is. There is also for mini test, there is also mini test auto run, but because this is an RSpec workshop, we're going to do RSpec auto run. So auto run means that when I run this code, I have this plugin in Atom. It's called Atom Runner, and it allows me to run this file and then we can see the output. Okay, so that's what this auto run is doing. Right now it's empty, so there are no tests. Notice it says no examples found. So in RSpec language, an example is a test. It's one singular test. Okay, so example and test in RSpec, there are interchangeable terms. Okay, so the example that I want to do is a circular buffer. Circular buffer. What's that? Well, a circular buffer is like an array. So you know arrays, you can have 1, 2, 3, you can have things inside the array. Well, a circular buffer is just like that, but with a limited size. Okay? So for example, we can have a circular buffer of size 3. That means that it will be basically an array which the maximum size is going to be 3. And when we put something else into the array, when we add something, the oldest item, so for example, this one, it goes away. So that's what a circular buffer is. You're explaining this so you understand what we're going to be doing here right now as the code example. So now, how do you write an RSpec test? Well, it's very easy actually. The first thing you do is create a describe block. What's a describe block? Well, a describe block allows you to group examples. So group tests together. Okay, it's simply that. And the describe block needs either a string or a constant. So, well, I wanted to write this circular buffer. So that's our describe block. And remember, this is for grouping tests together, or in RSpec language, grouping examples together. So that's the first thing we need to do. And now if I run this, we get our first taste of TDD. Why? Because we get an error. So typically beginners think that errors are bad and that you have done something bad. But in TDD, errors are good. Errors are your friend. Why? Because errors give you feedback. Errors tell you what to do next. Okay? So in here we are reading this error. It means that we're missing the circular buffer class. Okay? Does that make sense? Because a class is a constant. So it says uninitialized constant. Well, that's a class in our case. So let's create our class and I keep passing the date, the time. And here we go. Now we go back to this. Okay? So the next step is that we need an it block. So the it block is the actual test. Okay? So the describe block, and notice this do. If you miss this do, you're gonna get an error. You need this do. The describe block is for grouping together tests. Now this it is for actually defining one test. Just like in Ruby, we do def something, something to create a method, right? Well, in RSpec, we do it to create a test. Okay, that's just the way it is. So what are the components of an example or a test in RSpec? And if I'm going too slow for you, I'm trying to make sure that I explain everything. Okay, if this is too slow, you already know all of that. You want me to go faster, let me know. So the it block requires a description. Okay, what is the description? Well, this is the description of the test. This explains what the test does. So for example, for circular buffer, we're going to need to test a few things. So right now I'm going to go back to this my map for a moment, okay, to explain this, because a lot of people ask this: what test should you write? What test should you write? Right now we are faced with our first test. What do we write? Well, I have a few pointers and suggestions and ideas for you. First, think input, output. Think input, output. What do I mean by that? Well, I mean that our program, or in this case our circular buffer class, you can think of this like a black box, okay? Visualize a black box, and you don't know what's going on inside this box, but you can put things inside the box and something comes out of the box, okay? So something comes in and something comes out, which is the result of the method or the class, okay? So that's what I mean by think input output. Think what you put inside the class and what you want to come out of the class. Another way to think about this is, what should this code produce? What should this code do? You have to describe the functionality of the whatever you are testing. How would you describe that, right? So that's another way to think about this. So this first two is what we call the happy path. Is what supposed to happen in the best case, in the ideal situation, in the ideal scenario, okay? And then after that, you can also write tests for edge cases, special cases, and branching. And by branching, I mean like if statements, loops, things like that. Okay, so now let's go back to the practice. Now, what do we need the circular buffer to do? Well, as per the description, we're going to need a way to add items. Okay, we need to add items into the buffer, and we need to make sure that this feature of being a fixed size, so fixed size, we need to check that, right? And we also need to be able to add new items. New items. Items. So basically we need to write tests for these two things. We need to verify the behavior, okay? So let's write that as our first description. It can add new items. How about that? Now, what are we doing here? Well, in here, first we're going to need a buffer object. So let's create that. And we don't have an initialize yet, but I imagine that I want something like this, right? So right now, if I run this, we get a failure. Okay, so this will be the red stage of the TDD. So remember these three steps: red, green, refactor. We are on red right here, on red. Why? Because it says failure. And remember, failures in TDD are correct, are expected. So what does this say? Well, it says ground number of arguments given 1, expected 0. So what that means is that we need an initialize with size argument. And we are back to working. So we are back to, technically we are on green now because we have this dot. So when you get this dot, it means that you have passing test. The test is correct, is working. Okay? So let's just go with this flow. Let's continue with the test, because this in itself is not a test. This is the setup, the preparation for the test, okay? So for the actual test, we need to write an expectation. So to write expectation, we say expect something, we don't know what yet, to equal something. So this is like the basic template for a test, right? You have your describe block, then you write your it blocks, and then you write your expectation. So what is the expectation? Well, this is where the rubber meets the road, right? This is the real thing. This is where we are expecting something to be something. So let me give you a concrete example. We're going to expect the buffer size to equal 1. Okay, so let's do that. And now we have a proper test. And we're back to red. So yes, we're kind of skipping the refactor step right now because it was not a complete test yet. So now we have a complete test. What makes a complete test? Well, we have the setup and we have the expectation, okay? So now I run this, we get the failure, which means we are on red, and we just follow the feedback. What does the test want? It wants undefined method size. It means that we have to define size, just like that. Now it says expected 1 got nil. Okay, so let's give it 1. And we are back to green, just like that. Okay, so in the TDD tradition, the more hardcore or more poor way is to just do the minimal amount of code to make the test pass, so to make the test green. And that's what I just did here. So now what we need is to write another test. Well, actually, there is something missing from here, which is that we need to add something into our buffer. Okay, so let's add the number 1, and this will trigger us to add another method, undefined method this. So let's do that. Okay, so now we can write the next test. How do you write another test? Well, it can add more items. That will work for now. And then we need this again. Okay, let's use the same size. And now I want to add 2 items. So now I'm going to expect the size to be 2. Why? Because now I'm adding 2 items, and here I'm adding 1 item. And now we get expected to got 1. Okay, expected to got 1. Where is this coming from? Well, this expected to is coming from here, from this line, right? So we're expecting buffer.size to be 2. So that's why we get expected to got 1. We got 1. Why? Because we are hard coding 1. So now this test forces us to generalize the answer. Okay, so how do we make this work? When we are in here, what we need to think is, how do we make this work? How do we make it return true and not break this other test? Well, we have to actually implement the thing, right? So let's do it. So we're gonna need some internal data structure. And here we're going to need to add the values. And in here, let's just return the size. And I think that's going to be enough. And yes, so now we are green. So we went to red, which is writing the failing test. Now we are green because the tests are passing. How do I know that the tests are passing? Because we're getting dots. So the dots means passing test, okay? And it also says 0 failures. So let's quickly review what we have done so far, okay? So we wrote 2 tests. The tests are these it blocks. which are inside the describe block. Each of these tests has a description, okay? They have some setup code, some preparation for the test, which is this and this. And they also have some expectation, which is this and this. The expectation is how you say what you expect to happen, what should happen. In fact, this on older versions of RSpec, instead of expect, this said something like buffer size should be equal to that instead of expect. But the newer versions of RSpec use expect for checking this equality. So it says EQ, which means equal. Okay. So that's that. Now we are here. We are in the refactor phase. So let's actually do the refactor phase. We are on this, on the bottom of the cycle. How does this work? Well, we look at the code and we look for opportunities to improve it. What opportunities do you see here? What things can we improve? What things are repeated, for example? Well, if we look at this line, aren't these the same? Yes, they are. So is there something that we can do to reuse them in some way? Well, I have good news for you. Yes, we can. There is something called the let statement, and we use it like this: let buffer, and then we just move this code into here. And now we can remove that. We run the test. So when you are refactoring, when you are on this refactor phase, okay, you want to make sure that you're not breaking your code. And the test helped you with that. So I ran the test, they're still passing. Okay, so how does this let work? Well, this let creates a method for you, and when you call that, it's going to create your circular buffer for you. So it only creates this once. Okay, it's like a cache. It keeps a cache once you call it once. So when you call it again, inside the same test, it's going to be the same buffer. So in here, buffer, this is going to be the same buffer. And it's also this let, there is two versions. There is let exclamation mark and regular let. What's the difference? Well, the difference is that the regular let is what we call lazy. It's a lazy version. What does that mean? Well, it means that this, whatever this code is going only to work when you use it. So if I don't say buffer in here anywhere, let's say that there are no buffer, then this doesn't get created at all. But if I have this question mark, then it always gets created no matter what. This is the non-lazy version. So this only matters if you're doing something like database, creating records in the database and things like that. So it's something to remember if you are using let and you run into some strange behavior. So that's the end of the cycle. So we went from red to green to refactor. The refactor was moving this into let, the circular buffer creation, into this let expression. Okay. Now, what do? We go back into red. Why? Because we're not done with our implementation. Imagine this a feature. You're implementing a feature. Doesn't have to be a class like this. Well, for the feature to be implemented, it has to follow some specs, some specifications given to you by the client or whatever, right? So when do you know that you are done writing tests? Well, whenever you think that you're implementing your feature, your class, whatever, your jam, does all of the things that it needs to do. In this case, we're still missing this part. We're still missing fixed size. So we need to go back to red, which means writing another test to verify this behavior. So how do we write this description? It can only have a maximum size of elements, something like that. If you have more time, you can think more about these descriptions. But for now, let's go with that. So what do we do now? What do we do now? Well, let's put some items into the buffer. Let's put 4. Okay. And now we're going to expect that the size of our buffer is 3. So notice that we're putting 4 items, or maximum size is 3, and we're checking that it's 3. So this should fail. And it's important that your test, when you're writing it in the red phase, it should fail. Why? Because if it can't fail, then it's not useful. It doesn't give you feedback. It doesn't tell you what to do next. And if your application breaks, you make some change and it breaks, the test won't tell you that it broke, that you broke something, right? Because if it can fail, it's not useful. So this failing, as you can see, we get .f, and we get this information. It says failures, and it says expected 3 got 4. So that's exactly what we were expecting, because we're not doing anything in here to make this remove the extra elements. We are not enforcing this rule, this specification of this circular buffer, right? So how can we implement this? Well, we have to think a bit. How about this? We need the size. So let's save the size. Okay. And now let's check the size. So if buffer size is greater or equal than this size, let's do something. Now here's one thing. We are still on red and we're going towards green. Okay, we want to make the test pass. Now if I want to make a change, I want to make change, for example, the name of a variable, you would only do this during the next phase, during the refactor phase. Right now, our only thing that we want is to make this work. We don't care at all about best practices or nice code or anything like that during this transition from red to green. Your only goal, this is important because a lot of people get stuck here trying to write the best code. But during this transition from red to green, which is what I'm doing now, implementing, you only want to make the code work. Okay, that's your only goal. So now let's do that. Let's make this work. So let's take the buffer, and remove one value. And I think we can use the shift method to remove one value. And we are back to green. We are passing test. Okay. So 3 examples, 0 failures. And remember, examples is the same as test in RSpec language. So we are back to green because we are passing the test. And the next step is looking at refactoring. Are there any opportunities to improve this code? Well, maybe we can rename this size instance variable and make this max size. Why? Because that will allow us to make it differentiate from this method. So we have this size. How is this size different from this size? It's not clear. So let me make this max size. So I'm going to select and make this max size like that. And that's a refactoring. And when you refactor, you run the code. You run the test, and it should pass. So we should be green at the end of the refactoring. At the start and the end of the refactoring, you always should be green. Okay, so you don't move into writing a new test. You don't go back to red until all of your tests are passing. Okay, so let's review. If you are following along with me, I'm going to show you everything we have done so far. If you have any questions, you can type in the chat. I don't look at the chat very often, but I have my brother looking to see if you type something, he will let me know. So I see another opportunity for refactoring here, which is doing this. And it's working. So we have this circular buffer class. It has 2 instance variables, it has 2 methods, and it has 3 tests. So are we done yet with this example, with this circular buffer? Well, it does what we think it should do. It allows us to add new items as verified by these 2 tests, right? And it allows to only have a fixed size, as we can see here. So this should be enough for this class. If you want, then you can try to think of special cases or edge cases, and then add more tests to test for that. But for now, we're going to move on into the next topic, because we still have a lot of topics to go. And yes, you're going to get this mind map after, so don't worry about that. So how do you structure your test correctly? That's the next topic, this one. Well, there are different levels of structure for your test. The first level is called arrange, act, assert. Arrange, act, assert. And this level is inside the it blocks, the tests themselves. So let me show you how that works. So these 3 things. Arrange means the setup. So I'm going to add comments so you can see how this works. So the setup is already happening here in the let block, but I'm going to move it here in line so you can see what this looks like. Okay, so this would be the range. Then the next part is called act. So acting, what does that mean? It means that we are doing something. Okay, we're adding things into the buffer. So in this phase is where we exercise the behavior that we want to test. So this is like calling methods, and yes, as you can see, this is a method that we want to test. And finally is the assert phase. So assert is the last phase, Asserting means that we're checking if whatever we did here is working or not according to this expectation. So that's one way to arrange your test, is to follow this pattern. And it's called arrange, act, assert. And you don't need the comments. I just put the comments in here so you can see how this works. Okay? So for more complex tests, for more when you have tests where there is a lot of things going on, you can come back to this pattern from arrange, act, assert, and you will know that you have the right organization. Okay? So that's arrange, act, assert. Now I'm going to delete that, and I'm going to show you another level of test organization, and that's inside the describe block. So inside the describe block, you can create something called a context. Okay, a context. So we can say context do, and this also has a description. For example, we can do new items, right? And we can move these tests that are related to adding new items inside this context. And then we can create another context, and we call this maximum size, for example. And we can move that test in there. So that's another way to organize your test. In this specific example, in this example that we have right here, I wouldn't do this. I would not do this. Why? Because we only have 3 tests. There is only 3 it blocks, right? But if you had more and you need to organize this test, then these context blocks help. Okay? Another example of these context blocks, let me show you the example, is, for example, you have login, like user is logged in, right? And then you have test for when the user is logged in. So typically we say something like when user is logged in, then we have this test. And then you can do another like this when user is not logged in. So that would be one example of using this context to organize your test. Okay? And there is one more level of organization. So there are 3 levels of organization. 1, inside the tests themselves. 2, with context blocks, as I just show you right now, with context, the description, and then you put the test inside. That's the second level of organization. And the third level is the file level. Okay? What do I mean by that? Well, right now I have everything in one file, but usually what you do is you create a new file and you will call this the name of the class that you are testing. So if in Rails, if you're testing a model, you will call this the model name. If you're testing a controller, you will call this the controller name. So in this case, we are testing circular buffer. So circular buffer spec RB. So notice this underscore spec. That's important. So RSpec knows this test file. And notice also Atom gives me this different icon. Looks like this chemistry testing proof thingy, the icon. So now what I could do is I move this into there, right? And here I would require relative my file where the actual implementation is. and I would move that right here, and then I run this. Of course, the test ran twice because I didn't save this. There we go. So usually this how you and also you will have like another folder used for the test, another folder used for the test, and we call that spec. So I move that in there, right? And there we go. And now we are testing just this, and this instead of app, I will name it circular buffer. We can clean this up. Okay. And I think, oh yeah, we need to change this as well. Circular buffer. So this file level organization. So every feature, every class, every thing you are testing, you are going to have a file that's named like this, and it's inside some spec folder where you have all of your tests. So that's file level organization. This is the third way to structure your test. So that covers how to structure your test correctly. Quick review: one way is to use this pattern, arrange, act, assert. Second is to use context blocks. Third is to use spec files and a spec folder. Okay. So next thing is testing mistakes to avoid. So I picked some mistakes that people like to make. No, they make because they don't know any better. Okay, and what are these mistakes? Well, mistake number one, número uno. So it's, you know, I'm Spanish, so número uno is number one. So multiple expectations in one test. That's the first mistake. What do I mean by that? Well, imagine that in here, instead of having 3 tests, we just drop everything into one, like that, something like that. Isn't that kind of ugly? Well, we want to avoid that, obviously. But some people don't know any better, so they just try to stuff as much as they can in one test. But you want to have different tests for different things, right? I know it sounds basic, but it's something to keep in mind, especially as you get into more complex projects where there is a tendency to do that. And also, these specs, you want to try to only have one per it block. You can have 2, sometimes and 3, but most of the time you use one to have one of these. Okay? So that's what this means. That's the mistake. The mistake would be to try to test a lot of different things in one of these it blocks. Oh, and this another thing. Just notice this pattern for description. You don't need to add it can, whatever. You can just do it adds new items. It adds more than, or we can say adds 2 items. It only has maximum size of 3 elements. So you don't need to do the it can because it can get very repetitive. So that's another thing, the descriptions. So let's go back to our mind map. Next testing mistake to avoid is that, well, the mistake is testing implementation instead of behavior. Testing implementation instead of behavior. What do I mean by that? Well, let me show you. So in this code, what is the implementation? Well, implementation is the fact that we're using a buffer as an array, right? You see this line? We're using a buffer as an array, but that's what we call an implementation detail. An implementation detail. The users, so if I'm using circular buffer right here, size 5, for example, I don't need to know that there is an array behind the scenes. So when I'm using this buffer, I don't need to know that there is an array behind the scenes, right? Because that's an implementation detail. Similarly, when I'm testing this class, I don't want to do anything that's reaching into this implementation detail. So what would that look like? Well, if I define this attribute reader, and let's call this buffer, now I can access this internal array. And now I might be tempted to, instead of using this size, to access internal size and do it like this, right? Of course, this is going to work, but what happens if I decide to change this to something else, or I just decide to rename this, or whatever, I decide to change the implementation details, then my tests are going to break, right? So you don't want to reach for these details, you just want to use these methods, that the public methods that the class gives you. So that's what is meant by this second item right here. You want to test the behavior, not implementation. Testing the behavior means that you test what the code is doing, not how the code is doing. That's the difference. You're testing the what, not the how. The what, not the how. Okay? And that's what we're doing here. We're testing that the size is 2. That's the what. The how would be that we are actually reaching out into the buffer and we're testing this array and what's happening to the array and all of that. So that's the second testing mistake to avoid. And the last mistake to avoid is testing the framework or the language or the gem. For example, that will be validations. Okay, so if we have a validation in Rails, something like validates age presents true, something like that, we don't have to test that. Why? Because it's already tested. This is already tested in the Rails code base. Rails itself already tests that this is going to work. So you don't have to write a test for this. Now, there is an exception to this, is that if you write a custom validation, it's possible to write a custom validation in Rails, then you want to test that, right? But the built-in validation, you don't have to test that. I see people that want to test the built-in validation, but it's not necessary. Okay? At least in my opinion. If you think differently, that's okay. I'm just telling you what I think and what works for me and a few other people. So that concludes this section. So let's quickly review. We review what's TDD, test-driven development, how to do it, you follow the 3-step cycles, what test should you write, you think input, output, what should this code produce, what are the specifications for this feature, how do we know that it's working or not, right? And sometimes for that, you might need to, let's say that you are writing like Fibonacci sequence or some other thing. You always want to hard code this value. You don't want to calculate the value right here in this part. This value should always be hard-coded and not calculated if possible. So that's that, and you use these levels of organization and you avoid these mistakes. So next, let me explain something else before we move into testing Rails applications. I want to explain something else about RSpec, which I think is important. So in here, we have this expect, which is always the same, but we also have this EQ. Now this EQ part can change because this is called a matcher. So let me write that for you, matcher. This part is called a matcher and it can change. There are different kinds of matchers. For example, there are matchers to check for arrays, the contents of arrays. I think it includes or include question mark or something like that. You can find this in the documentation. You search for RSpec matchers, and you will get the whole list. And with this, you can test different things besides equality. You can test arrays, you can test exceptions, you can test other things. You can test even floating point values, decimal values, all kinds of values. So that's called RSpec matchers. Okay, so now let's move into testing with Rails. If everything is understood so far. So for testing with Rails, we're going to create a new Rails application. And it's not going to be anything fancy, it's going to be something very simple. It's going to be a books application, okay, where basically we have a catalog of books, a list of books. So to create a new Rails application, of course, we do Rails new, and let's call this books TDD. Okay, I'm going to add this -d. What is this? Well, this says skip the test. You can also do / skip test like that. But it's shorter to just do -t. And when I do this, it's going to skip minitest. It's not going to create the minitest folders. So by default, Rails uses minitest, okay? But we're doing RSpec, so we're going to skip minitest. So the command for that is, I passed it in the chat. Oh, sure, Sebastian, I will explain that again. So I have a request on the chat to review the circular buffer example really quickly. Let's do that. So circular buffer is like an array, okay? So an array, you can have items, but an array can have unlimited amount of items. So you can have 2, 3, 4, 5, and as many as you want, right? But in the circular buffer, what this is a limited size array, So we say circular buffer new size 3, and what that means is that the maximum size of this array is ever going to be 3. Never can have more than 3 elements. That's what a circular buffer is. So if we try this code, if we copy this into, let's say I open a RB session right here, paste this, I do buffer 1, buffer 2, buffer 3. Now we have 3 elements, right? If I do buffer 4, notice we still have 3 elements. One of them fell off, is gone. If I buffer 5, again, the size is always the same. This actually can be used to limit memory when you have like login messages and you only want the most recent, right? You want the most recent free messages or the most recent free something or 10 something. And you don't care about the oldest ones, you only want the most recent in memory. So that's what a circular buffer is used for. And this is how it works, right? You can add as many elements as you want. The size is always going to be fixed. So I hope that helps understand the concept. Okay, so again, this is the command for Rails. Got it, perfect. Thank you. I'm glad you understood that. That helped. Let's go back to Rails. I create a Rails application called Books TDD with the -t option. So -t, remember, is for removing Minitest. So Minitest is still here somewhere, but it's not actually being used by Rails. It's not creating testing files. So now the next thing that we need to do is we go into this books TDD project, and we're going to open the gem file. Okay, and in the gem file, somewhere around here is okay, we can add the gem, and the gem that we need to add is rspec rails. So gem rspec rails. So if you're following along, you open the gem file, add this gem. Okay, then we save the file and we run bundle. So this is going to install the gem for you, so you can use it. And the next step is another command. And for this command, I need to go to my notes because, yes, this command. So the command is this: Rails generate rspec install. Rails generate rspec install. That's the command. Okay, and this is going to create some files for us. As you can see here, create.rspec, create spec, rspec helper, and Rails helper. So we need those to be able to write our test. So what we did just now, well, we created a new Rails application, scrolling up using this command. Then we added rspec rails to our gem file. We did Rails, we did bundle, then Rails generate this. You have these commands in the chat if you are watching this live. Next, well, we need to write a failing test. So remember the TDD cycle, right? It's red, green, refactor, red, green, refactor. Hopefully you remember that. So the first step is red. So this goes back to this step right here as well, these two steps. What test should you write? Well, we need to think what does this code need to do. And we're writing a very simple Rails app. And what I like to do is to start with a controller test. Okay? Back to my notes. This is the command that is going to create the test for us. So here's the command. And we're going to take a look at this. So notice the file name is books_spec.rb under spec request. So we open that and let's take a look. So the first thing we say require Rails helper, that's fine. here we say aspect describe. So this aspect part is not really required, but you can leave it there, it's fine. Then books, type request, we can change this to describe. So you can use describe inside describe, and this will act like a context. So describe and context are the same thing. And I think literally they are the same thing. Describe and context in this way, you can nest them. But I don't like this describe because we only have one test. So now let's empty this description. It's a placeholder description. And let's say it can list all the books. And then let's see what's happening here. Get books path. What's this? Well, get is going to load this path, and then we're going to get a response, and we can assert something. So remember where we assert, arrange, act, assert. This or assertion. This will be act, and there is no arrange here because there is nothing to arrange really, but this will be the act phase, and this will be the assert phase. Okay. And in here we are expecting that the response of doing this action, flooding this route, and I'm assuming that you know what a route is and what a path is, because one of the requirements for this class was basic Ruby on Rails. Okay. So we get the response and we assert that, we check that, we verify that, use different names for the same thing, that the HTTP status is 200. What does that mean? Well, this means that this works, is an okay response, is a successful response. So this all that we need for this specific test. Now, how do we run the test inside a Rails application? We just say rake. Use rake like this. So you say rake to run the test. And now we can see TDD in action. This is our failing test. This is the red cycle, red step. We got a failure, an F. And remember, that's fine, that's part of the process. And it says books can list all the books. So define local variable method books path. So let's fix that. So if you know some Rails, you will know that we need to create a route, right? So let's go to the routes file. So config routes, and let's create a route for that. So let's do resources, books. Okay, resources, books. Then we create our route, as we can verify by writing rake routes. Next, let's run the test again and see what changed. Okay, so we have a different error. That's good because it means we're making progress. And now what does it say? It says uninitialized constant books controller. Well, of course, we don't have a books controller. We haven't created one yet. So let's do that. So let's do the app controller books controller. And let's type class books controller application controller. So this is standard Rails stuff right here. Nothing special going on. And all of that I'm doing here is just following the feedback that the tests are giving me in the form of error messages. So I'm going to run the test again, type in rake, and I get a different error. Why? Application controller. Maybe I mistyped something. Let's see. Oh, it's 2 L's. Application controller, no control. I missed 1 L. So that happens. There we go. See, the tests are guiding me by the hand, basically. You just need to read the errors, pay attention to the errors, because a lot of people just think that the error is something you're doing wrong. No, the errors are giving you feedback, and this is very important to do in TDD. And we're still on red. We're on the phase between red transitioning into green. So action not found, the action index could not be found for books controller. So what do? Well, we implement. So let's go here, books controller, index, end. And you don't have to go in here and start typing instance variables and all of that, because the test didn't tell us to do that yet. So we don't need to do more than the tests are asking for. That's part of TDD. So I'm running the test again, and we see a different error. So books controller index is missing a template for this request format and variant. So again, we need to give the test what it wants, which is a view. So views, books, we need to make the folder, and then app views books index.erv. So in here we can say something like maybe percent equals at books size. Think that we do for now. And let's run the test. Undefined method size for nil class inside the view. And why is that? Well, because there is no books, right? So let's fix that. Let's go back to the controller, and now we need that book.all. We do rake. What's next? Oh, initialize constant books controller book. It turns out that we don't have a book model, so we need to create that. So view models book.rv choose by okay, so let's do class book application record rake. What's next? Could not find table books. So what's next? Migration. So Rails generate migration, create books. So this is the migration. Let me give you that. Okay. So this again standard Rails stuff. You just need to understand these errors and just let the errors take you by the hand. Basically, let them guide you. Trust the test, trust the errors, and just follow them. So now rake td migrate and rake again. So every time that you make a significant change, you keep running the test until we are green. Oh, and we are green. Ta-da! So one example, 0 failures, and you can see the color is literally green. You didn't see it in here because this doesn't show colors, right? But in here, you can see we're literally green, and we have the dot, we have the 0 failures, and what that means is we're done with this first feature, which is being able to list books. So in the controller, I like to test response code, redirects, and objects being created on the database. And this thing needs to be bigger. Let me make this a little bigger for you. For 10. Okay. So in here we test. Let me open the test again. I find it there. We just test that we have an HTTP status 200, and you're already seeing just this test already drove the creation of the model, the creation of the view. So it already drove a lot of the things that you have to do anyway to make this work. So this is a good starting test. Next, let's implement the create, because in Rails, a controller has different actions, right? We have the index, we have create, update, edit, new, all of these actions. So we're going to implement create. So I don't like can't, but for some reason I'm adding can. It lists all the books. So now there is no refactoring, I think. So I'm going to skip the refactor and go back into red. Okay, so we are back into red. Next test. So you always want to be right here. You want to be either writing a new test, like I'm doing now, or making a test pass, or refactoring, improving the code. One of these three. If you're not doing one of these three things, then you're not doing TDD. Right? So let's write our next test. So it creates books. So for this, I'm going to do a post. Let me look at my notes right here so we can get this right. There we go. So I'm going to give you that line. So this is a post because creating books, if we go to our, hold on a moment. We go to rake routes there. It's a post action. Great, it's a post action, right? So this is back from Rails basics. That's why I'm doing a post. So let's go back to the spec. Notice the act. Remember, arrange act. Assert, nothing to arrange here. We just act, which is means we are posting, we are sending information to our path, to our Rails application, and then we're going to write our assertion or verification or expectation, whatever you want to call it. So we can do this, and that's fine. But when we are creating or we're doing something that affects the database, I like to do something else as well. And that's to check that the object that we're creating the book has actually been created. How do we do that? Well, spec book count to equal 1. Okay. There's another way to do this, but then it breaks our flow or a structure, this structure. So for now, I'm going to go with this. And if you want, you can keep this as well. So we have two expectations. Okay. So this is the create action. I'm going to save the file and run the test. So this is great. We have another failing test. So you can see the green dot and the failing test. And it's asking for us to create to write a create action. So let's do that. And again, we just follow the feedback. Follow the feedback. That's the name of the game when doing TDD. So let's go here. We create We create. And notice I'm just writing the method, not doing something extra. That's part of TDD as well. Just create minimal code to make the test progress. So rake, we run the test. And there are automated test runners if you want to do that. There is one called guard, and you can use that if you don't want to manually be running the test all the time. But for this, I'm just going to run them manually using rake. So let's continue with our test. Now it says expected 1 got 0. Expected 1 got 0. This is coming from our expectation that the book count should be 1. Of course, if you go back to the code, it can possibly be 1 because we're not creating anything. So let's create the book dot. I'm going to do new book params, and then we're going to write the book params. This for the strong parameters. Book params, and this is going to be params require book and permit title author. I think that's about right. Okay, I'm just going to leave this on screen for a few seconds so you can copy it. Okay, so next we need to get our book, and I could just say save here, and that will work. Should work unless, let's see. Okay. But it was 2428204. So I'm going to do the following. I'm going to do if render okay. Okay, missing template. Oh, I don't want to render okay. Sorry about that. I want to just return okay. I don't care about the template right here, so I just return the code to 100. And we are green. Okay. So what I done here is I create the book, and I created this because strong params. If you don't know what strong params is in Rails, you can look that up. But we have to do this to be able to save the book. And then I do if book save, I just return the code to 100 instead of rendering a new view. I'm just doing this for the purpose of this example. In a real application, you would render something, right? So we are back to green, right? We are back to green. And we are here, we are testing response code, redirects, and objects being created on the database. So redirect, let's test and redirect. For this, we have to go back to our red face. I think there is nothing to refactor, but let's take a look. Do we have something to refactor? Let's see. I think this is fine. How about our books controller? This looks good to me for now. So no refactoring. Let's write our next test, or failing test. So back to red, and let's do here. So what I want this to be? Well, let's say that the book cannot be created for some reason, right? So this the positive action, it works. Now we are going to test it doesn't work, like the negative action, it doesn't work. So it redirects to new if it can create a book, something like that. So for this, I'm going to post. Instead of a title, I'm going to do author. And in here, I'm going to do expect response to redirect note to redirect the new book path. Redirect to new book path. So I think that's correct. Let me check. Right. Yes, that looks about right. So this is the new test. And we're testing that we are redirected. And this is how you test a redirect. So remember how I mentioned matchers? By default, you have the EQ matcher, but in here we are releasing other matchers. So this is the have HTTP status matcher. And here is another, redirect to. Redirect to is another matcher. So matchers are just ways to test this thing, to test the response in this case. Okay? So now what I want to do is to add a validation to our model. So let's go up, models book, and we're going to validate title present true. So remember, we don't test the validation, but what we're going to test is that the controller does the right thing when the validation is found or triggered in some way. That we can test. Okay, so I run the test and I get expected response to be a 300 redirect, but was 204 no content. So we have to go back to our controller and just add an else statement here. So else we can do redirect to new book URL. So in the controller you have to use URL. So this is what I did. I just add a new branch that redirects to the new book URL because that's what we are testing in our spec. So we are missing the title that we trigger the validation, and when that's triggered, we're redirecting to this. So what we are testing really is not the validation. We are testing that the controller can handle the error that the validation is triggering. And then it does the right thing, like redirecting to the new book path. So we should have a green, and we do. We are back to green. We have free green test. So we are back to green. And now let's see if we can refactor something. This looks good to me. How about the controller? This also looks good. So there is no refactoring to do. And we are done with that. So that's the controllers. Now you can also test models, and what I would test in models are scopes and custom validations. Scopes and custom validations. So let's do an example of that. Let's write a model test, and I believe I have this in my notes, or we can do this. Let's do this. Respect model. Then we open this in spec models, book spec. We can delete that. And here, let's create an it. It what? Let's create a scope. It returns books with authors. So that's going to be what I want to do. That's my specification for this scope. And let's say expect book with author size to equal 1. Okay. So let me save this. And this is a model spec. As you can see, it says type model. And this is the file name. Okay. So let's run this. As always, we get some feedback. Failures undefined method with author for book. So what do we need to do? Well, we go to the model app. As you can see, the process is always the same. Scope with author. Then this a lambda. And in here, what do we do? Well, we're not author nil. Well, this is already the whole implementation, but okay. Oh, it's with authors in plural. So that's our scope. Okay, expected 1 got 0. Now, here's something important. Okay, I'm going to go back to the model spec. And what happens here is that we need something very important for this particular test. And that's that our database is empty. If our database is empty, how can we possibly test this scope? How do we solve that? Well, we need to create some books. Okay, we need to create some books. Give me a second. Just drinking some coffee here. Okay. So how do we handle this? How do we handle needing some things in the database? Well, the easiest thing to do is to just create them right here. So we can do book create, title, whatever, A, and then author A. Just for simplicity, and then book create title B, but no author. So this creates 2 books in the database, and then one of them has author and the other doesn't. So this is going to match with our expectation here, okay? So now if I run the test. It works. So we are back to green. So let me go back to here. This is probably not something that you want to do in production, because you might want to reuse this. Well, you can do this if you want, but it's going to be a lot of maintenance, right? Because you probably, as you have more tests, you probably want to reuse these books, right? So what's the solution? The solution is to use something called fixtures or factory bot. So let me write that for you. Fixtures, or factory bot. You use one or the other, but not both. So two of these two things, they solve the same problem, which is to create simple data for your test, right? So particularly like fixtures more because they are built into Rails. Fixtures are built into Rails, and factory bot is a gem, and you have to learn something new. You have to learn another gem and how it works, and you are introducing another dependency, another moving part into your application. And that's fine if you like factory bot, but and this used to be called factory girl before, but they rename it. So this was factory girl, now it's factory bot. Okay, so that's a gem. And then fixtures, it does a very similar thing, but it's built into Rails. So I'm going to show you an example of fixtures from a real project. So I have a project called courses, and this is a real production project. I'm using fixtures in here. I'm also using Minitest because I personally like Minitest more, but if you want to find work as a Ruby developer, then you want RSpec. That's just the reality of the situation. So having said that, let me show you what fixtures look like. So in fixtures, you have a series of YAML files, and they look like this. If I open this, they look like this, right? So you create the different books or users, products, lessons, courses, whatever you have, fruits. I don't know what your application is about, but you create in here the example data for your application, okay? That's what fixtures are for. In this case, I have two users. I call them active user and inactive user. You call them whatever you want. Usually it's going to be something that relates to your whatever your application is about. And then I define the email and I define the encrypted password. This for device. Okay, so this line is specific to device, but the other lines you can put whatever you want. And this is what you use in your test. How does this work? Well, you can find more information in this link. Why do you prefer? Oh, well, I prefer the mini test for a simple reason, and that's it. It's built into, it's part of Rails, okay? So when you add Rails, it already has mini tests. You don't have to do everything that we did with the gem file and doing all of the lines of RSpec init or whatever, RSpec initialize and all of that. It feels like more natural to use mini test, right? And I also like the syntax more. So if I show you one of my tests for mini test, I have here, for example, this one for Stripe payments, right? I'm using mini test, and it feels more natural to me, the syntax, but maybe it's different for other people. Anyway, like I said, for work, most people want RSpec just because it's more popular, and that's that. Other people prefer Minitest. Also, RSpec has more features built in, so I understand why people prefer RSpec. So Minitest just that, it feels more, I don't know, more integrated, more built in, or more natural for me. There are less parentheses, and here we have expect, parentheses, 2 equal 1. Here, no parentheses, right? And this as a response success, for me, is better than having to say to have, I don't know what it was. Let me see. It was something else. To have HTTP status 200 versus as a response success, right? It reads differently, but that's that. But anyway, what you're learning here, it's also applicable. The concepts of this TDD cycle and of that also applies to Minitest. And pretty much everything in our mind map also applies to Minitest. So right here, we are in this models section. And yes, and we're doing the model spec, the model spec. So let's go back. I got derailed for a moment, sorry, because we got a question about Minitest versus RSpec. Hope I answered that. So let's go back to here. We are green. And yes, I know where we are at. I was explaining fixture and factory bot. Why is that necessary? Because we need to have sample data for our test, like this test for the scope, right? And the solution is to use one of these things. So that's model testing. And you can also test plain Ruby object. What is a plain Ruby object? Well, a plain Ruby object is just this, like our circular buffer. That's a plain Ruby object. The difference is that we're not inheriting from Rails, we're not doing application controller, application anything. It's just a regular Ruby class. And if you're using this in your Rails application, then you also want to test that, okay? I'm not going to show an example because we already saw the circular buffer example. It's the same process. Only that you put the files inside Rails. So that concludes testing Rails applications, at least this section, and we're moving to the next section, which is how to test things you can't control. How to test things you can't control. How do you do that, right? Well, you do this in a way that you replace the thing that you can control by another thing. That's what mocking and stubbing is. A stub, so this is a bit of theory for you. A stub is you replace something that you can't control with something you can control. What's an example? Well, an API, an external API like GitHub's API, Facebook API, Twitter API. You can't control the API, right? But what you can do is you can replace that with something that you can control, with an object that you create or something that you can actually control. That's what we call a stub. A mocks or stub are very similar. A mock is different because you are testing methods, the methods that are called, right? And with a stub, you are just replacing the thing. So for a specific example, I have an article on my website which goes on about this. I also have a video. And if we go to Ruby Guides, rubyguides.com, and we find this article. Let me see our post mock this one. In here I have concrete examples. Cool, thank you, Jesus, no problem, you're welcome. This goes into how to use a mock. So inside a mock, you're doing this. You expect your mock to receive a method call. So in this case, a method call is calling flip, right? So that's a mock. Oh, yeah. And it looks like this, right? And the stop is created like that. So I'm not going to cover this because in Rails, what you're going to be using more specifically is something called BCR, which is the next point. I just want to understand the general concept of what a mock is and what a stop is. Remember, a stop is we're replacing something we can't control with something we can control. That's what it is. And that's how you create a stop in RSpec. Now, what you're going to be using most of the time is BCR. What's BCR? Well, let's take a look. So again, if I go to my real project right here, I'm using Stripe. So Stripe is a payment gateway where you can take payments from users. And to test this, I don't want to use the real gateway. I don't want to make real payments in my test. So what I do is I use BCR. What's BCR? BCR is a gem that does this. It does mocks and stops for you. And it replaces the Stripe's API, GitHub API, Reddit API, whatever API you're working with by something else that you control. So the way this works is you say BCR use cassette, and then you give this some name and a block. And inside, you do the action. So this post, or get, whatever you do, goes inside the BCR block. And then the gem takes care of everything for you. It automatically replaces the response from the real API with a prepared response. So what does that look like? Well, if I go to spec courses test BCR Stripe purchase, it creates these files, and in these files it has the response. Okay, so I don't want to show you the contents of this in case there are some API keys, because this is a real application. But if we create this and this match and this match, oh, I have so many windows open, and this match this name, you see an inactive user, new user. If I go back here, you can see where we at. So many things happen. Test BCR Stripe purchase, inactive user, new user, right? So in other words, if you are testing anything like an API, something that requires an API, like GitHub, Stripe, PayPal, all of that can be tested using BCR. And I'm going to show you, I'm going to give you another article where I go more into depth into that, which is this article right here. Okay. Okay, so the last thing I will say here is that you can control time. So to control time, to stop time, you use something like timecop, which is a gem, or if you're using Rails, you use travel to. So let me give you an example. If I go here, I open the Rails console. So the current time is this is my time sign, right? That's the current time. Now if I want to change the time, maybe because I have some test that we are testing scheduling, we are testing appointments, we are testing event times, anything like that, we probably want to control the time, and we do that by replacing the time. So I have some examples here in my notes. So we need to require this. So this is not necessary for your test, but is necessary in Rails console. Okay. So I'm going to copy and paste this in case you want to use this for right now to test along with me. So these are only for Rails console. Okay. Now what we can do? Well, we can play around with time. We can time travel. How about that? See, we can do travel to 10 minutes ago and the time changes, but it only changes inside the block. So now if I do time the current, the time stays the same. If I do travel to, the time inside is changing. So we can time travel. Okay, and instead of minutes, you can do seconds, you can do days. So everything that Rails can support, you can do. You can also do 3 days from now, and that's going to move into the future, right? So that's how you use travel to test time. And if you want to do this outside of Rails, there is a gem called timecop, like that. Okay. So that covers how to test things you can't control. And let's move into aspect tips and tricks. And this is one of my favorite sections. It's also the last section, and then we're gonna have time for questions. So aspect tips and tricks to make yourself a better Ruby developer. Well, let's see those. I love this part. So we can do bundle exec aspect as another way to run the test. So normally we can do rake, right? But you can also do bundle exec aspect. And why is this important? Because this will allow us to run these tips. The first one is filtering test. So we have many tests. Let's say you have 100, 200, 1,000, 1 million tests, right? And you want to filter them. How you do that? Well, you use bundle exec aspect and then use the folder. For example, that's one way to filter. And then we just run this kind of test. Let's say that you only want to run model test. Well, you do that. And now we just run only model test. So this can save you a lot of time if you want to focus on one particular kind of test. Okay? Now you can also run a particular file, specific file like that. Just say the full path of the file, and you can even run a specific test inside a specific file. So you can get very granular here. How do you do that? Well, if I open book spec, I want to only run this test, then I can look at the line number, which is 10, and then I can do colon 10 like that, and that only runs one test, which is the test on that file, on that line. So this can be very useful if you're trying to focus on one specific test. Okay, and there's another way to do this, is that if we go back to, let me show you this. Here, every test has descriptions, right? Well, we can run test by the description as well. So the way to do that is bundle exec aspect, and then notes a grades, like that. And what does this do? Well, this filters by the description. Okay, filter by description. So I find these options, these different filtering options, very helpful, especially as your testing suite grows. As you write more tests, you have hundreds of tests maybe, then you can very easily filter them in different ways. Okay, so that's the different testing options. Now let's take a look at the next tip and trick for aspect. So these are specific for aspect. Although if you're using Minitest, there's also equivalent ways to do this. So in Minitest, you can also filter tests. In Minitest, you also have different formatting options. There is also test runners, right? So the documentation format, this is one of my favorites as well. The documentation format, you invoke or you use it like this. So this means F for format and D for documentation. F for format, D for documentation. So you can remember that. Okay, and what happens is, as you can see, when you run the test, you get the dots. But when you run with this format, this is called the documentation format, we get this very nice output that uses the test descriptions and the test names to generate this output. So it says book returns books with authors, books with this controller lists all of the books, creates books, and redirects to new if it can create a book. So the nice thing about this gives you a very nice overview of all of your tests and what's going on and all of that, right? And this is also a good way to see your test descriptions all in one place. And you can combine this with the -E option, so you can find the descriptions you want to filter by. So that's the documentation format. There are other formats. I believe there is a JSON format. If you want to use that for something, there is even an HTML format, I believe. You can find all of the formats in here. These are of the formats. You can even do a custom format if you want. So that's really nice and helpful. And here's one bonus tip. Do you want to make this the default? If you want to make this the default format, you can. How? Well, you open this file, which is created for you, but you can change it, and we can do FD. So format documentation, we save this, and now by default, when I run aspect with rake or with bundle exec, by default we get this format. So if you like always having this format, you can have it by changing the dot, notice the dot aspect file in the root of your folder. Okay, so that's how you do that. That's a nice bonus trick for you. And so other tricks is that you can use a test runner. Test runners, the most popular one is called guard, specifically guard aspect. So you can use this. What we do is automatically run your test. Okay, I don't think we have time to cover how to use it because we are already around the 2-hour mark. But it's not very hard to get it to work. The hardest part is this. Let me give you an overview of how this works. So guard, the way it works is it looks for patterns. Okay, for patterns, and the pattern is basically a regular expression, and it looks for these files matching this pattern, and when these files change, when the files that match this pattern change, then guard will run the corresponding test. So not only if we run the test automatically, it will only run the test for the files that change. So I find that's very nice. And if you want to get this going, you can go right here and follow the instructions. And if you're having trouble getting this going, you can email me and I will try to help you make it work. But it shouldn't be too hard if you follow the instruction and you understand the basic concept. So that's guard, that's a test runner. You can even make this show you a little window here in the corner, and it shows you test passed or test failed. So that's nice. On to run guard, you say when it's properly installed, you say guard. I will run. So that's guard, that's test runner. This also works for mini test if you like mini test. And final tip I have for you is to use the profile flag. So you can do / profile. I mean / not dash or minus profile. And what this does, it enables the profiler mode. It enables a profiler mode. So as you write more tests and more tests and more tests, your tests are going to begin to slow down, right? So right now we have 4 tests. This takes 0.2 seconds, but it's going to increase. It's going to be 1 second, 5 seconds, 10 seconds. Now, how do you improve this? Well, you need to find out which ones are your slowest test, and you do that using this profile flag. So you can see here we get top 4 slowest examples, and it says, oh, this takes this long, this takes this long, this takes this long. And then you can go and investigate why is it taking so long. Is there a way to make it faster, yes or not, right? So that's a thing. It can be very helpful as well when you have many tests. So that's the last thing I have for you. That covers the whole mind map and our 2 coding examples. And now I'm going to open this up for questions. I'm going to send you the mind map image as well as the recording of this session. So it's question time. If you have any questions about what we covered, if you want me to go deeper into something, if you want me to explain something more depth, we have some time here to do that. Where do you place the test for plain Ruby objects in Redis? Good question. Good question. Well, we have the spec folder, right? And you can make usually these plain Ruby objects, we sometimes call them service objects. So in this case, we will call this service folder, right? If you prefer something more generic, maybe you can use I don't know, objects. I just use service objects. You can do make the objects, or maybe plain Ruby objects. Some people like to call this plain photo, like that. I don't like this. It means plain Ruby object or something like that. But just pick one and go with it, and you will find it. So when you run expect, as long as your files are ending like this, _spec, rspec will find them, okay? And as long as they are inside the spec folder. So if I do a tree, right, you see everything goes under spec, and then every actual spec, actual testing file has to be this _spec. That's the important part. Know the actual folder. You can call it whatever you want. I suggest services, so this will be plural like the others, or you can use objects or something else. Cool, thank you. Can you bring a better sense of functional integration unit? Oh, yeah, that's a really good question as well, Sebastian. Different kinds of testing, yes. So it's necessary to make all of them in Rails. Yep. I understand what you meant. Yes, that's a great question. So there are different kinds of tests, if you didn't know this. So let me add a branch here, kinds of testing, so you know what we're talking about. So the kinds of tests, we have unit test, we have integration test, have system test, which is different than integration test. We have acceptance test. So there are these more different kinds of tests. So let's go over a bit about the differences. Okay, you don't have to have all of them. There is something called the testing pyramid. The testing pyramid that you can look up, and it says that you want to have more unit tests than other things, and unit tests in this case will be the plain Ruby object test, the model objects. So testing the model scopes, that will be a unit test. Testing the validations, that will be a unit test. Testing the methods in a plain Ruby object, that will be a unit test. Now, an integration test is what we have done here with the controller. The difference is that with a unit, you're testing one little thing, one input and one output. With integration, you're testing different things working together. That's what we have done with, well, not floating topic. That's what we have done with the controller test. We test different things coming together. So that already covers two things. Now, a system test is when you are testing the user interface. So you can use this, you can have a few of them to cover your most important parts of the interface. So let's say that you have, oh, and here is also where you test things like JavaScript. So at this level, you can test JavaScript. At this level, you don't test JavaScript, you just test the request flow, right? So request flow. So what levels of tests do you have to have? Well, for very important features, so you have to rate the importance of your feature. For example, payment, being able to pay for a product if your application takes payment, that's a pretty important feature that it works, right? Or being able to create new users. So for that, you can create system tests. So system test, it simulates your browser, and for that you use Capybara, right? And you say, click here, fill this form, click this button, click this link, and then we check that what happens after that, it works. Then integration, we're not clicking things, we're just visiting a website. So for a very important feature, you want to have everything, every test possible, including manual testing. For less important features, for your regular day-to-day features, just use these two, right? The thing with system tests is that very slow, right? Because it simulates a real browser. But these ones are a lot faster because you don't have to do that. Right? And acceptance test is a different kind of test where you're testing something, this for legacy code, more or less. So let's say we have a program and we have no idea what a program does. So you're given the circular buffer, for example, and you don't know what it does. So what you do is you write a test that is not a failing test, it's a test that passes, it's a passing test. So you match what the class is already doing. So how does that work? Well, if I were doing an acceptance test for this, I will just put whatever value in there. I don't know what to put, right? Then I will run the code, and then I get whatever is there in the code section, right? The two, and then I put that in here. So it's like in reverse. It's like, I call this reverse engineering test. And then you use this. So what is this kind of test useful for? You use this for legacy code, for when you have old code that doesn't have tests and you don't know how it works, well, you write an acceptance test. And you do that like I show you. You put whatever value in there of what you want to test, and then you mirror the value that's already given you, right? So that's reverse engineering test for legacy code. But in your regular code, mostly you're going to be focused on these two unit, which is just testing one function, one method, one thing, without involving multiple things. Integration, multiple things, the controller, system, multiple things with the user interface, JavaScript, HTML, CSS, everything, the whole thing. Acceptance, legacy code. Legacy code. Right? So that's the different kinds of testing that you can do. Like I said, to answer your question, you don't have to have all of them. It depends on the kind of feature you're working. It's very important, more testing, less important, less testing. So I hope that answers your question. And if you have a specific example, maybe we can discuss more, we can talk more about that. But this is in general, how I think about this. Cool, are system tests the same as functional test? Well, good question. I think functional tests, they're more like the integration controller tests that we have done during the Rails example. Because we're testing the specific functionality. In fact, if we go to Rails guides, functional test, let's have a look. This looks, let's see. There, functional test for your controllers, right? So was the request successful? Was the use redirect to the right page, right? So these are the things I'm testing in what I call an integration test in here, the controller test, basically. So it's basically the same thing. Yes. No, system test. No, that will be integration test. No, system test is one level above that. Because in here we're not testing UI, but system test one level. So if you imagine a pyramid, so let me search this for you. Testing pyramid right here. This is good. You see unit tests on the bottom, meaning you have to have more unit tests. Integration test, which will be also named controller test, functional test, request specs or test, or integration test, all names for the same thing, right? So this can be called either integration, controller, request, or functional. Yes, it has many names for the same thing. This is basically capybara, right? So system test in right here in this image, this called UI test. That's one level above the functional test. Okay. So you can look at this image if you want. There's also this one, right? So that's called the testing pyramid. Testing pyramid. Let me give you that link. So, awesome. Thank you. Thank you for watching and asking good questions. What will be a suggestion for you for adding a test to existing Rails app that doesn't have any kind of test? Well, that's an interesting question. Well, there's different ways you can go about this. You can do the acceptance test that you explained to you, where you reverse engineer the code. So that's one way to go about it. There's a book called I'm going to recommend you this testing legacy code. It's called something like legacy code. Yes, this working effectively with legacy code. So this is going to be helpful for you. So this book explains how to go about that, about taking. So what you have is called legacy code, right? It's application without test. And this describes as legacy code in this book. And this book gives you different strategies. I believe, if I remember correctly, the code is in Java, but you should be able to apply the concepts in here. And if you don't want to buy the book because a bit slightly expensive, then you might be able to find it in Safari Books online. I think you might be able to find it in there for a lot cheaper, because it's like a subscription service, and they have even a 2-week trial or something. I'm not a sponsor or anything, just letting you know how you get access to this book for cheap and legally, so you're not taking anything, right? So that would be one way. You get a free trial and you can read this book. And again, I'm not affiliate with them or anything, but you might find that useful. This gives you strategies, but my strategy will be like write some acceptance tests, this reverse engineering kind of test for the important parts of your application, logging, some logic that you have. You're doing some kind of calculation, and test your scopes, test your plain Ruby objects if you have any. Yeah, that's that. And you're welcome. So that's the end of the workshop. If anybody has any more questions, let me know. You have a few minutes for more questions, and then we're done. After we're done, I'm going to send you my map, this my map right here, so you can use this as a reference or to remind yourself of what we have done today. You will have this for yourself in image format, so you don't need any special program to open this. It's just going to be standard image, right? Then if you want this, I can also send you this TDD cycle And there is also this image. I didn't make this one. This I found in somebody's blog, but I found this interesting way to think about TDD as well. This is like an expanded version of the TDD cycle, right? And if you want that, I can also give you a link to this image. So in fact, let me do that right now. To the workflow, I think that I can like that. Start that. Thank you, Miss Gisola, for watching. I'm glad you like the workshop. I plan probably to do more workshops like this on other topics. Is that something you will find interesting? I plan to do one on metaprogramming, Ruby metaprogramming. I plan to do more on how to do a JSON API with Rails and things like that. Okay, last minute for any questions. Last minute for question, and then we are done here. Also tweet out this workshop. Oh, thank you. Well, thank you for attending. This is the end of the workshop. Thank you very much for coming and showing up and watching and asking great questions. I'm glad you enjoyed this and learning something new. Thanks a lot. See you in the next workshop or other videos, other articles that you can read. Thank you. Bye bye.